Okay, good morning. We're going to go ahead and finish up our notes on gas laws. So we just finished talking about the combined gas law. You guys checked your homework and handed that in. And we're going to talk about our final gas law today, which is the ideal gas law. So first we need to look at what molar volume is. So go ahead and flip to the last page of your notes, which is on the back here. We're going to look at molar volume. Okay. So in order to convert moles to liters, we need this conversion factor, and that conversion factor is 22.4 liters is equal to 1 mole. Okay, and it's important to note that this is at STP. So at standard conditions, 0 degrees Celsius in 1 atmosphere, 24 liters of gas is going to be equal to 1 mole. So if we wanted to do a sample problem, ask here how many moles of helium are in a 3.7 liter balloon. So we're going to write down what we know, 3.7 liters. Move our units down. Okay, we know that there are 22.4 liters in 1 mole, and we're actually trying to find moles, so that's what goes on the top. 1 mole equal to 22.4 liters. We plug that into our calculator. We're going to get 0.17 moles. Okay, so I'm going to give you guys a minute to do the try it out problem. So I want you to do this on your own paper here. Figure out how many moles of hydrogen are in 4.9 liters of a balloon. Okay, you can pause the video, and as soon as everybody's finished, you can start the video again. Okay, so to solve this one, same as above, we take 4.9 liters. Move our units down. Okay, we're looking for moles, so moles go on the top. Our conversion factor, we know that 22.4 liters are in 1 mole. So we're going to go ahead and divide by 22.4. Our answer should be 0.22 moles. Alright, that's molar volume. So let's move on to our final gas law, and that's the ideal gas law. So first we need to look at the ideal gas constant. The ideal gas constant is actually R, and R is going to be equal to a number, which is 0.0821. Now the units of this number include all of the units that we've already talked about. So units of R are going to be liters times atmospheres divided by moles times Kelvin. Now the nice thing about R is that it's the same all the time. So R never changes, and once we look at our equation, it's going to have R in it. R is always going to be the same. You just plug in 0.0821. Okay, so the actual equation for the ideal gas law, this is a typo here, so cross out this R. The equation for the ideal gas law is PV equals nRT, or PIV-NERT. Easy way to remember it. I guess that's easy, I don't know. PV equals nRT. Okay, but when you solve this ideal gas law, your numbers have to be in the units that the ideal gas constant are in. So our volume needs to be in liters. Our pressure needs to be in atmospheres. And our temperature needs to be in Kelvin. And moles need to be in moles. Okay, so let's look at a practice problem. This first one here says, what is the volume in liters of 0.250 moles of oxygen gas? Okay, so the problem is asking for volume. Okay, that's going to be our V, whatever whatever it ends up being. That's what we're trying to find. Okay, so V, we don't know what that is. Then it says of 0.250 moles of oxygen. Okay, well moles, if we look at our equation, moles represent this N here. Okay, so N is going to be 0.250 moles. And you know what, while we're at it, let's go ahead and add to our notes that this N represents the number of moles. So I'm going to draw a little arrow there. That's moles. Our R is the gas constant, which is 0.0821. Temperature is going to be Kelvin, volume liters, and pressure atmospheres. Okay, so let's get back to our problem. So we have volume that we're trying to find. We have number of moles given. We have gas is at 20 degrees Celsius. Okay, so we know Celsius is a temperature. However, we also know we need to convert that to Kelvin. So we're going to add 273 to get that into Kelvin. So that'll give us 293 K. Okay, and then our problem also says that we have 0.974 atmospheres of pressure. So our P is going to be equal to 0.974 atm. And that's all they tell us. So in the question, they give us P, they give us N, they give us T, and they ask us to find V. So our ideal gas equation up here, PV equals nRT, should work just fine. So let's start plugging stuff in. Our P, 0.974. So that's P. V, we don't know that, equals N,